Okay, let's look at linear relations. And so linear relations really, for the most part, there's only one exception. For linear relations, they're all going to be functions, except for a vertical line. When you graph a linear relation that's a vertical line, that is not a function. So technically, most of them are going to be functions. First example, the graphs of three relations are shown below. Circle the linear relations, state the domain range for the information given, and whether the relation is discrete or continuous. So, for example, if you were to join these points up in the first example, they'd form a straight line. So they are a linear relation. This is discrete because they are not joined up. Okay, so in this case, the number of guests would be n, cost would be c, domain would be the n values. So just look at those points that have been plotted. It's discrete. So an n value of 0, 10, 20, 30, 40, 50. Doesn't mean you couldn't have other values, but that's what's on your graph. Your range would be one grid line before 500 is 400, and 900, and 1400, and 1900, and 2400, and 2900. And as I said, it's discrete. These are separate points. You can't have part of a guess, so it's discrete. Okay. Next one, it says domain approximate, because here, a little bit hard to tell. Time, this will be t. This is height, and it looks maybe to be about 12.5. Can't really tell for sure. But from 0 to 12.5 for your domain. So that's going to be all the t values where t is between 0 and 12.5. So t goes in between with inequalities, and then t is an element of the set of reals. Okay? Range is 0 to 800. Okay? So that is height from 0 to 800. Oops. And then I need to put the h in there. And h element of the set of reals. Okay, that's joined up, so that's continuous. And then the third one has points, but it's also joined up as well. And so time in minutes, time for horizontal, and altitude for the vertical. So domain, all values of t, where, and you got to look. So no arrows on the end, so 0 to 20. And that's t, where t is an element of the set of reals. Range is a, and that is from 0 to 10,000. So 0 to 10,000, a, where a is less than or equal to r. Okay, it's joined up, so that's continuous. Okay. Then take a look at the next table of values. So actually, let's go back. In terms of linear relations of a graph, if it forms a straight line, then it's a linear relation. So that's part A. In B, it is not. It's joined up and it's not a straight line. And make sure, though, you check the axis and make sure that it's scaled correctly. As long as it's scaled correctly, then if it's not a line, then it's not linear. If someone made a mistake in the scale, then you would need to check a little bit further. And then that one's a line. So A and C are linear relations. Let's take a look at a table of values. Okay, so number of guests here for relation A. So number of guests when you look at it is 0, and the cost is 400. That's basically the ordered pair, right? Then for 10 guests, it was 900. So we're just copying out. Actually, I can show this on two screens here. Give me a sec. on, and then we can look across here. Okay, so 20, if you look at your graph, is 1400, and then 30 was 1900, then 2400, and then 3400. 30, 40, sorry, 50 was 2900. Okay, I think there was an error on the answer sheet on that. Okay, and so if you take a look here, these are all increasing by 10. And for each increase by 10, this is increasing by 500. So you just want to make sure that's another way of checking that it's a constant rate of change, which means it's linear. B, if we take a look at the relation for B, then here time 0 is 800. Time equals 2 looks to be about 780, so we have to kind of estimate a little bit. 4 looks to be maybe about 720-ish. 6 looks to be about 620. 8 looks to be about 480. 10 is easy to find, that looks to be about 300. So now, as we're increasing these by 2 each time, this is decreasing by 20 in the first one. Okay, this is increasing by 60, this is by 100, etc. So they're not constant. So that's not linear. And this is linear. Okay. Note for relation A, every increase of 10 results in a decrease of 500, or sorry, increase of 500. However, in B, every increase of 2 results in different decreases of height. So for a linear relation, a constant change in the independent variable results in a constant change in the dependent variable. So I'm going to go back to my full screen here. Okay, and let's look at question 3. Which of the following relations are linear? Justify your answer. So this is increasing by 5, by 5, by 5. So that means these increases or decreases should all be the same. So here, this is plus 9, this is plus 9, and this is plus 9. Always check through your entire chart. So yes, that's linear. Okay, so for every increase of 5, increase 5, in this case, degrees Celsius, temperature, degrees Fahrenheit increases by 9. Okay. Next one, current. So we're going up by 5s, up by 5, up by 5, and this is up by 75, up by 225, up by 375. Not consistent. Okay, so this is not linear. So every increase of 5 in current gives different or varying increases in power. So the current and power equation is not linear. Next one, new cars purchased for $24,000. Every year, the value of the car decreases by 15%. The value of the car V is related to time T. So be careful on this one. It decreases by 15% each year, but it's 15% of the previous year. So if we did a table of values, here's the price. Okay, each, or sorry, this is the year and then the price. Year and then price. So right now it's $24,000. After 1 year, think about how to calculate that. So you take 24,000 and you subtract 15% of the 24,000. This is one way of doing it. Okay, so if you do that, then you're going 24,000 minus 15% of 24,000 is 20,400. Another way is to go think about if the price is decreasing by 15%, then what it is still worth is 85%. So if I go 24,000 times 0.85, so 24,000 times 0.85, I should get the same value, okay? So after 1 year, it's 20,400. After 2 years, now I have to take 85% of the 20,400. Okay, so if I take 85% of that, I get 17,340. And you can see right now that for this increase by 1 each time, this decreases by, 3,600. And then here, 20,400 minus 17,340 decreases by 3,060. Okay, so it's a different amount because you're dealing with percentages. You're taking a percent of the previous year, not of the original. So, is this going to be one? Yes. Is it really linear? So this is not linear. Okay, because the change in price is not constant. For a service call, an electrician charges $75 flat rate plus $50 for each hour. Total cost is related to time T. So this is kind of like the cost of a banquet hall. So this is time and cost. So probably you know that it's linear, but let's just check it out. So for 0 time, it's still going to charge $75 for showing up at your house, even if they don't look at anything. For 1 hour, it'll be 75 plus 50, which is 125. For 2 hours, 2 times 50 is 100. That's going to be 175. And so you can see, as you increase by 1, this is increasing by 50 each time for each hour that they stay. So this is linear. So constant increase in cost or constant increase in time. Okay, next one is written as a set of ordered pairs. So I kind of just like to take a look at what's happening to the x values. You could even make a table of values, but here x is increasing by 3, and then by 3, and then by 3, and then by 3. Okay, so what's happening to y? So y is subtracting 4, subtracting 4, subtracting 4, subtracting 4. So yes, that's going to be linear. Again, the same reason, all right? Let's look at the next one, table of values. Now we're increasing by 2 there, 2 there, and 8. That's increasing by 4 there. So we have to basically average that out. So here, this increase is 100. This is 100. And those are constant for these. Now, if I'm increasing by twice as much as before, is this increasing by 200. Well, no, it's still increasing by 100. So these aren't the same, but these are the same. These are not. Okay, or constant. Okay, so this is not linear. Okay, so for this should be 8, comma, so we did 200 should be 500. So it should be 8, 500. Okay, next one up by 10. And you've probably done this back in math 8 and 9, right? This is not new. You just maybe didn't call them linear per se. Okay, so up by 10, up by 5, up by 10. Let's see what happens here. Down by 20, down by 10, down by 20. So notice how they match up. When you're going up by 10s, it should go down by 20. And then when you're going up by 5s, it should be half of 20, which is going down by 10. So linear. Okay, got to match up. Okay. If these are linear, find the missing values. So we have to check with the information that's given there. So up by 2, up by 2. So we're just given 3 rows. This is down by 8, down by 8. So yeah, they're linear. So that means when I go up by another 2, I need to go down by 8 to get 4. Now I'm going up by 3. So for every 2, I'm supposed to go down by 8. So basically, you want to think about what's happening. So a ratio. So if we're going up by 2, we're going down 8 for the y value. So every 1 would be down 4. So we have to do this 3 times. 3 times 4 is 12. So we've got a minus 12 here. That's a negative 8. Okay. So think about the relation in terms of doing that. If we wanted to come up with an equation to represent that relation, then think about you would have y equals, and for every change in 2 for x, we go down or subtract 8 for y. So basically negative 8 over 2 times x, which simplifies to negative 4x. And then you got to check out what happens when x is 0. We need to get 28, so plus 28. So that would be y equals negative 4x plus 28. You want to find the change for every 1x. So if this is by 2's, 8 divided by 2 is 4, and it's the negative. Okay? So again, you've probably done a little bit of that in junior high, but we're going to do a lot more this year. Next one, this is up 4, up 4, up 4, up 6. Okay? So take a look. We can't see the pattern there. So it does say, so if each of the following are linear relations, so we have to assume that they are linear. So now here, what's happening? To go from the first row to the third, we're going up by 26. Okay? And these are all constant increases in x by 4. So basically, we want to think about what's happening. We want to divide that by 2. That means we have to go up by 13 each time. So this up by 13 would be 7. This up by 13 would be 20, right? Because there's basically 2 arrows to get from the first to the third. So we want to divide that by 2. So basically an increase of 4 in x is an increase of 13 for y. So now another 4, we have to go plus 13, so that would be 33. And then we're not increasing by 4, we're increasing by 6. So what do we want to do there? So basically it's another 13 plus half of 13. Okay, so it's actually going to be a decimal or a fraction. So that would be 6.5. So that would be really going 19.5. plus 33 is 52.5. Okay, what's another way of thinking about that? Well, every increase of 13 in y divided by 4 is your change for every one increase. Okay, so that would be, what is that? 3.25. Okay, then multiply by 6, that's 18, 19.5. Okay, so that's a little work on the side. In terms of an equation, not that you're asked to do it, but there's part of your work, right? So y equals, that would be 3.25x. Take a look, you don't have a 0 in there, but choose another value. If you have 12 to start, so go 3.25 times 12. Okay, and it's 39, and we really need to have it to be negative 6. So we've got to subtract 39 plus 6 is 45. Then try another one, 3.25 times 16. Okay, then subtract 45. Do you end up with 7? You do. Okay, so you can always check your work on that. And C. So here, what's happening? We're increasing by 3, increasing by 3, increasing by 3, increasing by 3. Okay, then what do we know? I'm going to use red here. So 1, 2, 3. So basically, we have to add, looks like it's increasing from 7 to 31 3 times to be consistent. So 31 minus 7 is 24. So we are going from here to here is 24, but we have to do it in 3 equal steps. So divide by 3 equals 8. Okay. So that's going to be 15 plus 8 is 23 plus 8 is 31. Okay. And that's your values. Okay. Let's look at the next. So rate of change, so that's what we were just doing. So the rate of change of a linear relation is given by the change in the dependent variable, so the y value, divided by the change in the independent variable. Okay, and that's how we were getting those equations they were talking about. So for each linear relation, to determine the rate of change, include units with your answer. So if it's an application, you do need to use units. So you want to take a look here. Basically, actually I'll use red. So we want to change, the rate of change is we want to look at the change in the dependent. So that's going from 400 to 900. So basically this here. Okay, so the rate of change, sometimes we abbreviate it, is, so really we're going 900 minus 400 over 10 minus 0. So that's really 500 over 10, which is 50. Now what are the units? That would be cost per guest. Okay, that means for each guest, costs $50. And you can kind of tell then, for 0 guests it was 400. So that 400 would be your flat rate or your flat cost or base cost or deposit. Okay, and then $50 per guest. So this is the cost per guest. Next one, what is it? Altitude and time in minutes. So again, I always start at 0 because it's easiest. So now my rate of change is my second, so I always go the second value over the first. So 8,000 minus 10,000 over 4 minus 0 in minutes. So that's going to be negative 2,000 over 4, which is negative 500. Okay, notice the negative in there. If you forgot, if you went 10,000 minus 8,000, you get a positive. But notice how this line is going down and to the right. The altitude is decreasing. So this means in units, negative 500 meters per minute, okay, or decreasing by 500 meters per minute, okay? So the negative and the decreasing mean the same thing, okay? So whatever it is, it's getting closer to the ground over time at a constant rate. Okay, next one, rate of change. So these are all increasing by 100s, and these are all decreasing by 15, so it is linear. Okay, so decreasing by 15 for every increase of 100, okay? And then reduce that. Or I guess you could show it, because it's a volume, you could show it as a decimal. So negative 0.15, and that's liters per kilometer, okay? So basically the gas is decreasing, right? So you're using it up. Decreasing at a rate of 0.15 liters per kilometer driven. Then here, these are all increasing by 2, so they're consistent. This is increasing by 4, right? So your rate of change is 4 over 2, which is 2. So this would be dollars per hour. So internet would cost $2 per hour. Okay, that's what that's saying. So in D, you're looking for the rate of change. So it already has the equation. So remember, as n changes, the value will change. This will never change at all, right? So this is your deposit, basically, that you never get back. 25 in front tells you how much it costs for each guest. So here, the rate of change equals 25, okay? And that's $25 per guest. Okay, next one, M is the mass in pounds and T is the time in seconds. So here, the coefficient of T is your rate of change, negative 1.3. What does that mean? So it's negative 1.3 pounds per second. Okay. And we are done.